Graphs of the functions f and g are shown below, intersecting at the points b, c and d0. Using definite integrals, write an expression for the area of the shaded region. If we look at this bit here, it only involves f. G comes down here, so it's not the area trapped between the curves there. But from A onwards, it is the area trapped between the curves. So for the first bit here, we have the integral from 0 to A of f of x dx. Because they cross here, we could use a modulus. So we could do the integral all the way from A to D of the modulus of f of x minus g of x dx. And that would give us the whole area. So we now want to do this when these are the functions. So we're going to have the integral from 0 to a. Now we need to figure out what the a is here. And the a is one of the points where g of x crosses the axis, and the other one is where they both do. So let's just work with the g of x, which is this one here. So let's go to graph and table. And then we've got minus x cubed plus 3x squared, add 13x, take away 15. We want to graph that, and we want the roots. So the first one is at -3. That's not one that we want looking at our graph. We want this one, which is at 1. So that tells me a is at 1. And then the other one over there is at 5. So this is going to be the integral from 0 to 1 of f of x, which is the 15 plus 12x minus 3x squared dx. And then we're going to have the integral from 1 to 5 of the modulus of 15 plus 12x minus 3x squared, take away negative x cubed plus 3x squared plus 13x, take away 15 dx. And we could just evaluate that on the calculator. So I might do these separately because there's a lot to type in here. So Math 2 is where we find the integrals. And we're going to go from 0 to 1. And that is going to be the 15 plus 12x minus 3x squared dx. So that's going to give me 20. And then we're going to want the other integral. So that integral we know is going to go from 1 to 5. And we're going to need a modulus in here. And so the first thing in there is going to be this function that we already have. So let's drag that down to there. And I think we're going to end up with a problem there because it's not got into the modulus. So I think we're going to have to do that via cutting and pasting. It would have been quicker to just type it out again. And that bracket's in the wrong place. This one here. So let's just get rid of it, and then make sure we're inside that modulus, and then we'll take away the other function. So that's minus x cubed plus 3x squared plus 13x minus 15, close bracket. Just make sure we're doing it with respect to x, and that gives me 32, so that's going to be 52 square units.